Let's talk about 3D printing in construction, or sometimes we use the term additive manufacturing. In recent years, construction companies have made great strides in 3D printing. The revolutionary technology allows companies to explore new structural forms, reduce waste and cost, and to improve the safety on construction sites. The 3D housing industry alone is estimated to reach $40 billion globally by the year 2027, which is a huge growth from a mere $70 million globally in the year 2017. When it comes to the housing market, building homes is time-intensive and costly. Firms around the world are innovating new projects to meet this challenge. From the Russian company's Apis-Cors concrete home that was printed in a mere 24 hours, to Austin-based startup Icon's $10,000 650 square foot home. As housing costs and urbanization continues to escalate across the globe, 3D printing homes offers a solution that is affordable, sustainable, and cost-efficient. The application of 3D printing in construction has been increasingly studied in recent years. Large robotic arms and gantry systems have been created to print building parts using aggregate-based materials, metals, or polymers. Significant benefits of 3D printing are the automation of the production process, a high degree of design freedom, and the resulting potential for optimization. 3D printing techniques are used in various industries to create physical prototypes as well as end-use parts. In the construction sector, architectural models have been created with these methods for more than a decade. Furthermore, recent years have seen vast increase in research on printing methods for building components, and the first construction projects have been implemented by applying 3D printing processes. 3D printing allows building companies to produce geometrically complex structures, to vary materials within a component according to its functions, and to automate the construction process starting from a digital model. These advantages can be exploited if the building components and the 3D printing processes are modeled appropriately in the planning phase. To this end, several digital methods for designing printable parts and for planning 3D printing process have been developed. In addition, file formats to store and exchange the resulting data have emerged. There is in fact an international standard for 3D printing. In the international standard ISO/ASTM 52900-5, 3D printing is defined as a process of joining materials to make parts from 3D model data, usually layer upon layer. It is an alternative to conventional manufacturing processes in which, for example, material is formed in molds or subtracted by milling. So what is a 3D printed home? Well, 3D printed homes are printed layer by layer using concrete as an ink, and they typically have four distinct qualities. Firstly, they have self-supported walls. Secondly, they have sufficient and appropriate thermal insulation. Thirdly, they are typically printed using recycled materials. And fourthly, they are designed and printed to make it disaster resilient. So how does 3D printing benefit housing? Well, 3D printed housing provides the following time and cost benefit while also offering new shelter possibilities. Firstly, it allows for unlimited design. The 3D printing methodology tracks the system to allow for flexible forms and flexible shapes. Secondly, it promotes sustainability. The precision of the printers saves on resources and energy use. Thirdly, it can be used to house the needy. There can be immediate housing for disaster victims and the homeless. And finally, it can be used as part of the space exploration technology, where the automated process can potentially create space bases. The 3D printed houses, they are printed seamlessly on-site using software design and on a thread-mounted printer, and that can save time and cost. There are a few stages. Firstly, software is used to create, scale, and model the whole design of the house. Secondly, the blueprint then becomes a code that sets the printer's movement. Concrete mix is then loaded into the printer to start the mixing or printing process. The printer creates and shapes the material one layer at a time. The layers are stacked in the set pattern until the walls are formed. The roof, windows, doors, and paint are added by hand. 3D printing for homes can offer low cost, high speed, and low waste advantages. They have the potential of solving housing crisis with affordable housing, combating natural disasters with immediate creation of shelter, and improving the construction industry with more efficient job sites. The construction industry faces serious challenge with productivity and waste. With the availability or ability to rapidly and precisely fill in the walls, 3D printing can conserve resources while maximizing the use of the staff for more hands-on processes, like using forklift to build the roof and manually place in the windows. The developments in 3D printed homes show that low-cost housing can be affordable, comfortable, and even elegant. The possibilities are real for millions of people around the world who struggle with basic housing. Although there are many benefits to 3D printing in the construction industry, there are still challenges ahead because 3D printing is still in its infancy. Buildings are actually complex structures that adjust to our living habits and provide shelters for all kinds of situations. Printed homes follow a set design. That means that it will be less flexible to change or to improve the design during the construction. While concrete is efficient, the technology is still being refined and not yet capable of producing smooth and perfect surfaces. The following are reasons or opportunities that can make 3D printing in construction industry become more mainstream and more adopted by the players in the industry. Firstly, conventional construction processes such as bricklaying, installation of reinforcement, and concrete casting involve heavy manual labor and are often dangerous. By increasing the degree of automation, 3D printing can reduce physical workload and therefore also improve workplace safety. 3D printing can also be used for construction projects under very harsh environments. For example, in places affected by natural disasters, war zones, or extraterrestrial locations. Therefore, NASA and the European Space Agency, ESA, have been conducting and supporting research on the use of lunar materials, that means materials that are found on the moon, for 3D printing techniques. The application of 3D printing processes can reduce labor costs. However, the smaller labor costs and the lower material usage could be offset by the more expensive raw materials and equipment that is needed for the 3D printing. Therefore, the project stakeholders need to do a cost-benefit analysis to find out whether is 3D printing advantageous in that particular project that they are considering. Furthermore, the production time can be longer due to the need for mobilization of the extensive 3D printer, and the part size could be more limited than in the case of conventional production methods. For this reason, many 3D printing processes and systems will have to be improved in order to take out this disadvantage. Apart from the aspect of automation, 3D printing offers great freedom of design. By combining and varying the raw materials during the 3D printing process, it is possible to produce objects consisting of functionally graded materials. Complex external and internal geometries can be obtained to improve the functionality or appearance of the building components. For instance, voids of different shapes and sizes can be included to make air ducts or wiring conduits. Moreover, lightweight cellular structures with mesoscales featuring sizes of from 0.1 to 10 mm or even microscale featuring sizes smaller than 0.1 mm can also be created through 3D printing process. It is also important to take note that in each step of the layer by layer wise production in the 3D printing, it has to be ensured that the printed part is stable and it does not deform significantly. Hence, support structures might be necessary during the printing process. Alternatively, the part can be designed in such a way that it is self-supporting during the whole manufacturing process. Another geometry-related constraint resulting from the layer-wise approach is the surface roughness. A smaller layer thickness or finishing operation can lead to a higher surface accuracy and smoothness, but that is going to lead to a longer production time.